Good afternoon, everyone. Welcome to Chem 111. I will be your TA for this semester. My name is YT1 Liao. Okay, YT is my first name, Liao is my last name. Since all of you are the first time to come over here, I'd like you to copy down my contact information. So, this is my email address and this is my office hour. I'd like you to copy down inside your contract cover. If you have any question or concerns, please email me directly or you can come to see me. Okay, since this is your first time to come over here, we are not going to do any experiment today. I will show you around the surrounding of this lab in the end of this class. But right now I'm going to do is to introduce a brief introduction of the experiment that you are going to do next week. So please open your contract and see the experiment 8, this page. The title of the experiment is the introduction of acid and base chemistry. Acid and base chemistry is the most important and common fundamental concept knowledge in chemistry field. The definition of acids and base, in fact, has evolved continuously throughout the whole chemistry history. So, in the very beginning, people differentiate acids and base through their taste. They taste differently. So, acids has sour taste. In contrast, base has bitter sour. And in 1880, Sir Arrhenius, a scientist, developed a more scientific and more specific definition for acids and bases. So acids are the substance what can produce proton. However, bases are substance what can produce hydroxide. And more recently, in 1923, Bornist and Lowry define that acids can donate acid substance which can donate proton, but base can accept proton. And Lewis theory define acid and base in a more. This theory is define acids which is electron acceptor. However, base is electron donator. Lewis theory is the broadest theory regarding to acid and base so far. So right now you know the definition for acids and base, and you also know that in our surrounding there are many basic substance and acid substance, like the soap you use in the bathroom, like the lemon juice you drink, like the lemonade you buy from Starbucks. So besides those things, I'd like you to know some common acids and bases we usually use in the lab, and we use that a lot, and you are going to use next week for your experiment. So these common acids we use in lab is sulfuric acid and phosphoric acid and also nitric acid. And for those common bases we use is ammonium, sodium hydroxide, and sodium carbonate. So over here, you have to you have to memorize and know how to write down the chemical formula for these common acids and bases, and also know how to write down the ionic equation and the net ionic equation. I don't expend more time on explain you what is ionic equation and net ionic equation, because I know you already learned from Chem 110. So what you have to do is go back home to refresh your memory and read the entire introduction in your chem track, and practice write these chemical formulas for these common acids and bases, and try to write ionic equation and net ionic equation. So for the experiment that you are going to do next week, first you are going to use an indicator to tell you the unknown sample is the unknown sample acidic or basic, and the indicator we are going to use is BTB molecule. So once you read your chem track, you will find this indicator, the name on your chem track, and I'd like you to do some study of this molecule. This indicator helps us to differentiate the solution is acidic or basic through the color change. This molecule have different color in acidic solution and in basic solution. So then we can differentiate the acids and bases by this indicator. So I'd like you to check the color of this indicator in acidic solution and in the basic solution. So then you will know what you're supposed to see in the lab next week. And second, you are going to do acid-base titration. So what are you going to do is that you will use a standardized acid and basic to titrate an unknown sample, which is a basic or acid, which is a basic or acid with unknown concentration, and in order to determine the concentration of your unknown sample. So for doing this experiment, you have to know how to calculate the concentration of an aqueous solution. So the concentration unit we are going to use is molality. So here is the equation. Molality is equal to the moles of solute over the liters of solution, and the moles of solute is equal to the grains of the solute over the molar mass of the solute. So here is an example that can help you to know how to calculate. For example, we want to prepare a 100 milliliter 0.5 molality potassium chloride aqueous solution. How many potassium chloride we have to add into water? So here is the potassium molar mass, which is 39, and the chloride molar mass, which is 35. So first step is we have to calculate how many moles of potassium chloride we need to prepare this aqueous solution. So by the equation, the moles is equal to the molality times the volume of the solution in liter. So over here, 0.5 times 0.1 liter of the solution, and so we need 0.05 moles potassium chloride. So then next step is how many grams of the potassium chloride that we need to we need to add into water. Okay, so 0.05 molarity times the mole mass of potassium chloride, which is 39 plus 35. So is equal to 3.73. So we have to add 3.73 potassium chloride into the volumetric flask and add the water to 100 milliliter, and then you are done. So and for the safety issue, you have to wear a proper attire. You have to bring your safety goggle, and you no shorts, no open toe shoes, and please tie your hair. So let me summarize what you have to do for next week. So first thing, please read your entire content. Please read the entire chem track that you are going to do for the experiment you are going to do next week. And second, please know how to write the chemical formula of these common acids and bases, and know how to write ionic equation and the net ionic equation. And 4, please know how to calculate molarity. And 5, check the color change for a BTB indicator. And please bring your goggle, no shorts, no open toe shoes, tie your hair, and prepare well before you come over here. And please arrive on time, then we can finish the experiment on time. And if you have any question, please email me, and let me show you the surrounding of this lab. Then we are done today. Okay. So then I will see you next week. Have a good weekend. Bye bye.